Welcome to Alien Space Education, where we journey through the cosmos to explore the universe. My name is Andy from Space for All Education. I'm your host today, and we're setting our sights on the mighty Jupiter and the incredible collection of moons. So mostly about the moons is all about today. The largest planet of our solar system, a staggering number of moons. So far we've confirmed 95. There could be more, we're still looking. These moons vary greatly in size, composition and characteristics, making a fascinating topic for both astronomers and space enthusiasts. So I really hope you like today's episode. Today we're looking at the most interesting of these moons. We're not going to look at all 95, it's far too many. We're going to look at the interesting ones. And these are, we'll begin with the famous Galilean moons, Io, Europa, Ganymede and Callisto, and then expand our discussion to include some of Jupiter's lesser known, but equally intriguing moons. Whether you're tuning in for a quick 15-minute overview or staying with us for the full 30 minutes, we've got plenty of celestial wonders to explore. So let's dive into the fascinating world of Jupiter's moons. The Galilean moons are named primarily because when Galileo looked at Jupiter, he saw 4 moons, and that's why they're the 4 main ones we see. So, introducing the Galilean moons. Galilean moons are diverse and a dynamic group, ranging from tiny, irregular-shaped rocks to massive bodies larger than some planets. They are divided in several groups, the most prominent being the Galilean moons. Galileo, who discovered them in 1610. These 4 moons, Io, Europa, Ganymede and Callisto, they have been studied extensively due to their unique features. So since the 1600s, we have been looking at these planets. We have lots to learn. Io, the first one on the list of Galilean moons, is mostly a volcano powerhouse. Volcanically active body one of the most volcanically active bodies in the solar system. Io is a fascinating world, fire and brimstone, with more than 400 active volcanoes on the surface. Even today, they're active. These volcanoes are constantly reshaping Io by spewing lava, sulfur, that give the surface a distinctive yellow, orange and red hues. Io's volcanic activity is driven by immense gravitational forces exerted by Jupiter and other Galilean moons, which cause Io's interior to flex and heat up, a process which is known as tidal heating. Now, I'm not quite sure you understand that, so I'll explain a little bit better. What it means is that Io is pushed and pulled together. The whole planet moves. Think of a stress ball. You squeeze it and you release it. You squeeze it and release it. Well, that's what's happening with Io. Jupiter is pulling it one way and it's getting squished that way. But then the moons, the closer moons, are pulling it back. So it's getting squished another way. And then it's getting a period where it's flexing back to normal. So because of that, the titanic plates and everything like that can't stay formed and everything like that, which makes it constantly active and everything like that. So this volcano's always going on. Because Io is extreme volcanism creates a thin atmosphere primarily composed of sulfur dioxide. Despite the harsh environment, study Io helps understand volcanic process that might occur elsewhere in the solar system. So these volcanoes could be elsewhere. These forces could be exerted on other moons, other planets in the universe. We don't know. But by studying it, we understand it. When we do discover it, we go, we know what happened there. Similar to what happened on Io. So we need to keep doing these things. Next, we move on to another amazing moon called Europa. Now, this one's completely different. It's a bit like the opposite. It's an icy ocean world. It's captured scientists and science fiction alike. Europa is a vast surface of ice expanding, but beneath the frozen shell lies a subsurface ocean, potentially containing more water than all of Earth's oceans combined. This ocean, kept liquid by the same tidal forces that heat make Io, makes Europa one of the most promising places in the solar system for search for extraterrestrial life. Now, when you're saying that, we're looking at under the surface, so we're looking in the seas. You think underneath our seas we have whales, we have dolphins, we have jellyfish, we have all sorts of animals. Maybe some of them live in the deep, dark, icy waters of Europa. The icy surface on Europa is crisscrossed by cracks, ridges, and evidence of dynamic process happening beneath. Future missions like NASA's Europa Clipper are set to explore this intriguing world in great detail, looking for signs of life and clues about the moon's geological history. So we are going there. Europa's Clipper is it's named Europa Clipper. It's going to Europa. It's going to go underneath it, and we're going to have a look, see what's there. And we're going to try and discover more about it. But it's also looking for signs of life as well. We know that underneath the Antarctic, we had drilled through some of the thickest ice there and had a look underneath, and we have discovered life that we didn't even know there that doesn't need to come up and breathe. So it's surviving in the water. It's breathing the oxygen. It's getting the oxygen from the water in complete darkness. So that if we can find out under the Antarctic, what can we find on Europa? Who knows? Moving on, the largest moon that Jupiter has is called Ganymede, the largest moon in the solar system, even bigger than the planet Mercury. So it's huge. This is unique in several ways. It has its own magnetic field because it's so big. Sometimes no other moon in the solar system has. It has its own magnetic field. That's the only one that has it. This magnetic field is generated by a liquid iron-nickel core similar to Earth. So it's bigger than Mercury, has the same core as Earth, and has a magnetic field that we have. Interesting. Ganymede's surface is a mixture of two types of terrain, highly cratered, so it's been hit by lots of things, ancient regions, somewhat younger, grooved regions. These grooves suggest tectonic activity in the moon's past. Beneath its icy surface, Ganymede may also harbour subsurface oceans, adding to another layer of intrigue to this giant moon. So what's that saying is, hang on, this is a frozen planet, a frozen moon. It's just like Earth, has tectonic plates that are moving just like Earth, but it's frozen. So it's a frozen Earth. But if the tectonic plates are moving, maybe there's tectonic activity, maybe there's volcanoes on it, underwater volcanoes just like Earth, and maybe that holds life in the water, because the lava obviously melt the ice, make water, and we have oceans, blah, 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 blah. So maybe somewhere in Ganymede and Europa, we have life living in the water. We don't know. We need to go there and discover it. So it's something to consider. We have these moons that could sustain life. It's not just Earth. And we're going to Mars. Who says that these moons aren't going to be next? Okay, the last of the Galilean moons is Callisto. It's a crater world. It's heavily cratered objects in the system. One of the oldest landscapes we've observed. Unlike its sibling, Callisto shows little sign of geological activities. Its surface remained largely unchanged for billions of years. This ancient landscape provides a window into the early solar system, offering clues about the process that shaped the planets and moons we see today. So even though Callisto has never changed for billions of years, maybe we can understand that to understand how planets are formed. So it makes it easier to understand how other planets are formed in other solar systems in the universe. Callisto has a thin atmosphere composed mainly of carbon dioxide and could potentially have a subsurface ocean, although it's less certain than Europa and Ganymede. So it could, but it's very unlikely. We don't know. We need to study it more. They're the four main moons. So now let's get on to the lesser known moons. While Galilean moons are the most famous, Jupiter's other moons also hold interest. Many of these smaller moons are irregular shaped and might capture and might be captured asteroids or remnants of early solar systems. Some of these moons, such as Althea, are closer to Jupiter and experience extreme radiation, while others, like Himalaya, orbit much further out and have a stable environment. So you've got to think these moons, Galileans are the ones we can see. They're easy to see. You can see them with a telescope. I've done it myself. Looked at it, they're beautiful. However, lesser known moons, they are so close or so far away from Jupiter that not only we cannot, they're very difficult to see, but the forces that they get exerted on them make them extremely different and unique environments. So close to Jupiter, you think if the moon was closer, it'd have a complete, it'd be turn, all sorts of things could happen to it, just like Ganymede or Io. The forces on those moons is going to be unbelievable. But Himalaya, further away, where those forces are less, means they're more stable. Who knows what's on them? Who knows what they're like? But they're smaller. So maybe there is life, maybe there isn't. Maybe there's an ocean we can't see, we don't know. But because they're so small, they make them harder to study. Okay. Future exploration, looking ahead for future missions, we will continue to study Jupiter and its moons. The upcoming Europa Clipper mission, set to launch in the mid-2020s, will conduct detailed reconnaissance of Europa's icy shell and subsurface ocean, searching for signs of life. Additionally, Europa's JUICE Ice Moons Explorer, or JUICE, mission will explore Ganymede, Callisto, and Europa, focusing on potential habitats of these ice worlds. Basically, we're going to see if we can actually live there. So we are going to have a look at more details of these moons. These solar shells are the largest, orbiting the largest planet in the solar system. So imagine if we lived on one of them, looking out, and every day you can see Jupiter. Be amazing. Each of these tell their own story, from fiery eruptions to hidden oceans. Europa, hidden oceans of Europa. These moons continue to captivate scientists and inspire future exploration. As we continue to learn more about them, we know this, and we know who knows what secrets they will reveal about its history of our solar system and the possibility of life beyond Earth. By studying these things, we're learning more. We'll learn not only about life here, but we'll learn life out there, about potential life out there. Who knows what's out there? We never know what we'll discover. Thank you very much for joining me on this journey through the moons. This is the short version. If you subscribe, I'm now going. There'll be a 30-minute version for those who have subscribed. I hope you enjoy it, and I'll see you next time. Next time we're moving on to Saturn. Take care.